Hey everybody, ABC 10 meteorologist Brendan Menchef here with another drought update. We're going to take a quick look at the drought map, which continues to improve, but really the focus of this story is El Nino. Where is it? We've talked a lot about it. We were looking forward to it for much of the spring and early summer. And where is it? It's just kind of stalled out. Things are quiet right now. We're going to talk to some experts, and we're also going to take a look at the data. So we'll start with the drought map. About 75% of the state is not in any drought at all. That's that base map gray color. About 20% of the state in that yellow abnormally dry color, and still just over 6% in the moderate drought category, which is great news that even though we haven't really seen a lot of rain, the drought continues to stay where it is and also make some small improvements. Talking about our reservoirs, still very full, 88% capacity at Shasta, 95% capacity at Oroville, and Folsom at 90% capacity. That's as of July 23rd. Now, the snowpack, we've talked a lot about it, is finally at its end, especially in the northern Sierra where the zeros and zeros appear for the average to date and the percent of April 1st average. In the central Sierra, we've got about 2% of that April 1st average left. Same down in the southern Sierra. Of course, that average to date is incredibly loaded because that doesn't even really mean anything at this point. It's that percent of April 1st average, which shows we still have just a little bit of snow still sitting in the central and southern Sierra, which coming up on the end of July is still pretty impressive. All right, let's talk El Nino at this point. First, we're going to break down what is El Nino. That's important that we understand what it is and what it looks like on a map. So here is what a typical kind of textbook idealized version of El Nino would look like. So you've got weak trade winds, which blow from east to west. And so with El Nino, it's important that those are weak. We're going to talk more about the winds in just a minute here. And then those currents, right? Those ocean currents start to push that warm water to the coast of South America, and then it floats to the surface and overspreads the equatorial Pacific. That is the hallmark of El Niños, where we got that warm sea surface all the way from South America on out into the equatorial Pacific. What that does for our weather in the wintertime in the United States is we'll typically have a wetter than average winter for Northern California. It's a bit of a toss-up, but typically the El Nino years come in a little wetter than average, especially for Southern California, though that is true. Warmer in the Pacific Northwest and across much of the northern Great Plains, drier in the Midwest. Now, with La Nina, which we just had and are now exiting out of, or have been exiting out of, as El Nino gets fired up. Here's what La Nina looks like just for reference, where we've got that cooler water just off the coast of South America and also Central America, and the trade winds are much stronger, which pushes that colder water further out into the equatorial Pacific and pushes the warm water even further to the East Pacific, or the West Pacific, excuse me. And the reason that's important that we recap this is because typically those La Nina years are drier than average. Again, a bit of a toss-up, but typically drier than average in Northern California, and certainly the case for Southern California. And for California as a whole, we typically have our drought years line up with those La Nina years. Also typically drier across much of the southern United States, also warmer than average as well, whereas the northern part of the United States is usually colder and wetter than average because of a strong polar jet that typically dips a little further to the south. All right. So that's what El Nino and La Nina are. So let's go ahead and start looking at the data, where we stand right now. So those sea surface temperature anomalies, again, I mentioned a minute ago that sea surface temperature is the key to kind of diagnosing where we are. Are we in El Nino or La Nina? So here's what the map looks like right now as of the filming of this video. Here's Australia, here's Papua New Guinea, and what we're really interested in is the equatorial Pacific, right around the equator. And what do those sea surface temperatures look like? So we can see that it is warmer than average. It's what those red colors represent near Australia and near Papua New Guinea. Now, as we work our way towards the eastern Pacific, towards South America, we also see a lot of those deep red colors starting to come into play. We do still have a pocket of cooler than average water. This is mainly just right near California and off to the south out towards Hawaii as well. That's kind of an artifact of the La Nina we had. What's really key right here is where we see that deep red color right off the coast of Peru and Ecuador, and you see just how much warmer than average it is. Again, that is key. That is telling us that we are in El Nino, which we are right now. The data supports that we are in El Nino. It's just a weak one as it stands. So to confirm this, here's what we're looking at. This is the El Nino status. This is for area 1.2, and so this is that area we just showed on the map a minute ago, right off the coast of Peru and Ecuador. And so this is kind of the first kind of bellwether, if you will, as to what El Nino is doing and how warm the waters are. And we can see that it's 3.1 degrees warmer than average, and that is right off the coast, again, of Peru and Ecuador. That's important because this next region The Niño 3.4, that's more out in the middle of the Pacific Ocean, right on the equator. And this is the number that we use to judge, are we in El Nino? How strong is it? Is it a weak one? Is it a strong one? Right now it is 0.8 degrees Celsius warmer than average, and 0.5 by United States definitions. Anything greater than 0.5 degrees Celsius is an El Nino. The opposite is true for La Nina, where if it's negative 0.5 or lower, then it is a La Nina. So we're obviously very clearly at this point in that El Nino status, but it is, again, a weak one. Once we get up towards 1 to 1.5, then we're talking moderate to strong, and then really anything over about, once you get towards about 2 degrees C plus 2C, that's where you start talking about those strong to very strong El Ninos. Here's another way we can look at where we're at with our water temperatures and those anomalies. That's really important, is the anomalies, right? So let's zoom into the top. And so what we're looking at here, this is right around the equator. So each, if you boil this down to little lines of, red or blue, it's all showing the same part of the Pacific, but what's changing is the time, right? So this starts at August of last year, then September of last year, then October, and then November, December, January. So we're looking at the same slice essentially stacked on top of each other for every single day since last August. And so what we see is in the West Pacific, right? This is near Australia, near New Guinea. That's where that warmer than average water was last year. And that cooler than average water right off the coast of South America was obviously La Nina, right? We're in La Nina conditions, and that's what we're looking at here. But what we see is that as we worked through November, December, we started to see that warm water start to erode that cooler water away, right? Here's January, February, obviously in neutral conditions at this point. And then certainly over the last few months, here's March, here's April, here's May, and you can see that warm water finally spread all the way across the Pacific. And especially we had a nice little pulse of that warm water move through right at the end of May through the first half of June. Recently, that has cooled off, right? We haven't had that fuel moving in. We haven't had that warmer than average water making its way across the Pacific towards South America. In fact, you can see it kind of has eroded right here just over the last few weeks, where we've seen that warmer pocket of water start to erode a little bit. That's because we kind of cut off that fuel source, right? We just didn't have as much of it making it in. But if you look just within the last maybe few days to a week or so, you kind of start to see that warmer than average water start to make its way back out into the Pacific a little bit. And that is what we're looking for. We're looking for those signs of life for the El Nino that supposedly should be building in any time now. Here's another way to look at this. This is the coast of South America. This is right around New Guinea at 180 degrees. That's your international date line. And so what we're looking for is we want to see that warm water making its way across the Pacific. And we do see that, right, where we've got a lot of that warm water out in the West Pacific. And then in the East Pacific here, right off the coast of South America, we do still have some of that warm water. Here's a better way to look at this, though. We look at the anomaly there, and you can see that pocket of warm water right off the coast of South America. But what we don't see is a lot of that warm water making its way back towards the coast. And maybe I should have explained this a little better. This is showing ocean depth, right? So this is the equator is what we're looking at here. And it's only the equator. But what we're looking at now is, instead of, if you think about it, a map on top, we're looking at a map stacked of the ocean. So this is the ocean surface, and now we're down 100 meters, 200 meters, 300, 400, 500 meters in depth. And so these lines right here are buoys, and they've all got sensors on them. And so that's how we're seeing this data. So this is underwater, right? The cycle goes like this. You get that water, it gets transported out towards South America. Then it's forced to rise up as it hits the South American continent, rise up to the surface, and then treks its way back out across the Pacific. And so it goes kind of in a circle like this, right? And so what we want to see to get this El Nino going is we want to see warm water beneath the surface, because that would be making its way to South America, reinforcing this warm pool of water, and eventually that would spread out across the Pacific. But that's not exactly what we're seeing right now. In fact, we've got cooler than average water making its way across. It takes quite a bit of time for water to make it through. It's not a matter of days or weeks. It's a matter of months in order to get from one side of the ocean to the other. So it's slowly making its way across. But in order to get this El Nino going, within the next month, we really need to start seeing much warmer water making its way out. And the way that we see that is via the winds. That's what we really want to see. Remember, I mentioned in a La Nina, we've got those strong trade winds which blow east to west, right? And that is what we don't want, because that's what keeps the warm water in the maritime continent, right? In the Western Pacific. And we want to see those winds weaken so that we can let that warm water kind of work its way back, slosh back, if you will, as one of our experts like to describe it, slosh back towards the South American continent. And so here's what the winds are doing right now. And this is right off the coast of South America, and this is New Guinea right here. And so this is your West Pacific, this is your East Pacific. And so what we see are those winds are blowing pretty strong in the East Pacific from east to west. But what we're starting to see out here is a reversal of those winds. Those trade winds weaken and in some cases start to reverse. And when we look at the anomalies, right, how far from average are those winds? Right now, we, again, have those winds east to west, which is fine over here. In fact, that's helpful because it'll blow some of that warm water out over the Central Pacific. But what we want and what we need to see are those trade winds weakening and then those western anomalies developing. And that's exactly what we're starting to see just over the last few days. That's what we started to see out in the West Pacific. And that, again, is helpful for fueling El Nino. And so if this can sustain itself and we continue to see some of these trades weaken and help that water slosh back across the Pacific, again, that is the good news that we're looking for. One of the things that could really help get El Nino going is the MJO, or the Madden-Julian oscillation. Kind of an abstract concept, but let's talk about it and kind of break it down a little bit. So it has two phases. It has a wet or positive and a dry. Essentially, here's how you can look at it. We have one phase where it's wetter and it acts as a low pressure system. Then we have another phase where it's drier and it acts as a high pressure system. That's really all you need to know. The other thing you need to know is that they orbit the Earth. I mean, they kind of move around the Earth. Not really orbit. They move around the Earth in the atmosphere right across the equator, right? And it does this every 30 to 60 days, and it just keeps doing it. It's a pattern. It doesn't stop. Sometimes it weakens. Sometimes it's stronger. But the way the MJO can help us is if we get a stronger phase of the MJO, that's a wet phase or one of those, that acts as that low pressure system. If we can get that going, it can actually help to start the El Nino back up by kind of weakening those trade winds, right? And another way you can look at it as a wave, right? So we've got the wet phase and we've got the dry phase, and it goes back to the wet and it goes back to the dry. And this pattern repeats itself across the equator, and it orbits all the way around, or I shouldn't say orbit, it's not really a proper term, but it travels all the way around the equator, and it takes about 30 to 60 days to go from where it started all the way around to back where it started. Now, another way we can think of this is that wet phase of the MJO, right, creates cloud cover, because obviously you have to have clouds to have it rain. And so we can look at the outgoing long wave radiation or the lack thereof, and essentially that just means, are there clouds that are blocking the sun from reflecting off of the ocean surface and going back out into space? And so the blue areas on the map are where we are forecast to see some of those clouds. And again, this is a way for us to kind of see what phase the MJO is in, right? Is it in that wet or is it in that dry phase, essentially? And so we are starting to see some of that blue, which indicates some cloud cover, right? Which maybe indicates an active phase of that MJO, right? And even as we work 6 to 10 days out into the forecast, this one here is 11 to 15 days out. So now we're in towards about the middle of August. And we see actually looks like potentially that MJO is going to get going. And that, again, would help weaken the trade winds, which would then help move some of that warm water out towards South America. And that would help strengthen El Nino. Again, this is not going to happen overnight. This is kind of a slow process. But what we're looking at is as we work towards somewhere like October, what is El Nino going to look like? Because really, El Nino is a fall-spring phenomenon. And in the wintertime is when it really has the biggest impact on weather here in North America. And so here's kind of a comparison of where the models are looking at. This is for El Nino, and this is from the Australian Bureau of Meteorology. This is their model here, and this is just comparing some of the other ones from across the globe. Here's the NOAA model, and here's the European model, two of the ones we talked about, right? The GFS and the Euro models. And so the Australian model, the Bureau of Meteorology, has it actually really, really strong at about 2.8 degrees Celsius above average, which would place it as a very, very strong El Nino at that point. Not sure I completely agree with this. I mean, it would really have to get going very, very quickly. I think the Euro and probably the American model are a lot closer here, and that's showing right around 2 degrees above average, which is actually still considered a high moderate or even a strong El Nino. And here's another way we can look at this. This is the CFS, the climate forecast system, the corrected El Nino forecast model. This basically, they apply a bunch of statistics to these numbers here and try to take the error as much as they can out of their math and out of their models. And so what we're seeing here is this model has it topping out right around somewhere between 1.5 and 2 degrees Celsius, which is probably where we're going to end up with this El Nino unless something really starts firing very quickly and we have a very sustained a kind of burst of that warm water and a very sustained MJO over the next month or month and a half. Now, that's just kind of a quick look at the numbers there, at the data, kind of forecasting that El Nino, maybe things that we can kind of look forward to and kind of pay attention to as, we go through really the next month, because that next month, really the month of August, is going to be very crucial for El Nino, how strong it gets, how weak it is, how quickly it fires up. We're going to learn a lot about it really over the next 30 days. Now, I talked to two experts about this, two people that pay very, very close attention to El Nino over the months. And even when we've been in La Nina, what they were kind of looking forward to, what can we expect as maybe we transition out of this finally and go towards El Nino? Well, now El Nino is building. Let me toss it over to the experts and you can hear what they had to say.
So last winter was really the start of El Nino.
Mark Sponsler, the owner and founder of StormSurf.com and an avid surfer, has weekly YouTube videos where he breaks down the weather and El Nino conditions across the Pacific.
We were still in La Nina, but it was a mixture of La Nina and El Nino. The very beginnings of El Nino were forming in the far west Pacific. There's this thing called the MJO that was getting fired up. It was pulsing the jet stream right at California. We got multiple atmospheric rivers coupled with the hangover or the remnants of La Nina making cold air, and the combination of those two just set up massive amounts of snowfall and rain into California, which we all know about, and which resulted in great things for our reservoirs and our water table.
I'll be honest, I did not see the kind of record-setting, endless onslaught of atmospheric rivers early in the season. I did kind of go back. This piqued our interest, right, in terms of it was technically starting in a La Nina winter, exiting out of it, strengthening into an El Nino now this summer. And we actually found that these kind of transitionary seasons, when you go from a La Nina to an El Nino, or even reverse, if you go quickly from an El Nino to a La Nina, some wild things can happen in California. We certainly saw that in spring.
Matt Reardon, a meteorologist with agricultural company Nutrient Ag Solutions, also does frequent YouTube weather forecasts for ag customers and other interests, not just for the West, but all over the United States. And El Nino or La Nina can often dictate whether a region sees a wet winter or a dry one.
So kind of May and June, a lot of these kind of forecast models that attempt to predict the ocean temperatures and how they'll change out into the future, they were predicting really strong El Ninos kind of at the end of summer going into fall. El Ninos developed a little slower than we thought. That's not uncommon, for summer. El Nino kind of typically more of a fall winter phenomenon. So I think we're just seeing more of maybe a typical late start to El Nino.
The way all this started is there's this thing called the MJO, the Madden-Julian Oscillation. And I'm not going to go way down the rabbit hole, but that's what was really firing up back in January, February, March. It's this periodic weather oscillation that goes in two phases, an active and an inactive phase. And when it's active, it basically just supercharges the jet stream and aims it right at California. And that's what created all our weather last, in the winter. And now the MJO, starting about the end of May, it just went to sleep. We had 5 or 6 massive pulses of the MJO, which set us up for last winter. And now all of a sudden it's just gone, oh, I'm going to sleep, and there's nothing happening. So we're sitting here watching and waiting, going, well, is it going to wake up, or is our building El Nino all of a sudden, right when it's supposed to get, supercharged and do its thing come September, is all of it going to fall apart, and is all the warm water off of Ecuador going to start dissipating? The good news is we're starting to see, the models have been projecting the MJO waking up just in the past. It said originally, most of the models were saying, well, sometime in early July. Here we are, mid to the latter part of July, and now there's better consensus amongst all the models that the MJO is in fact waking up. In fact, you can go look in the West Pacific, you can see the trade winds are starting to change there. They're starting to build a building area of precipitation and cloud cover over in the far West Pacific. So tentatively, it looks like, okay, maybe we're back in the game again. So there's trade winds that blow across the equator from Ecuador towards the West Pacific. And it's only a small area on the equator. That dictates the weather pattern for the entire planet over this tiny little area, 5 degrees north and south of the equator, and limited to the equator in the far West Pacific. When the active phase of the MJO moves over the West Pacific, it acts like a low pressure system effectively. And what it does is it dampens the trade winds there. And when you dampen the trade winds, that allows warm water that's normally piled up in the far West Pacific to start sloshing east.
Other than waiting for the MJO to kick in again, Matt is also keeping an eye on the typhoon season.
My attention is actually kind of drawn toward the Western Pacific, where we're seeing some potentially really strong typhoons spin up. And those are kind of like this backdoor way to kick a pattern in that wasn't there before, or kick a big ridge out that's been producing a lot of heat waves. So we'll watch that as we kind of get into prime typhoon season here at the end of summer and fall in the West Pacific. But yeah, those are two things we look at to kind of kick things out and start the pattern in the West.
So whether it be typhoon or MJO, something will have to happen in the Western Pacific in order to get our weather pattern to change.
I mean, that's sometimes how things work in the atmosphere, sometimes in life too, frankly, where it seems to be the same pattern for quite a long time, and then something switches, a match gets lit, and suddenly we're back into the regime that we expected the whole time.
Right now, we have a strong oceanic signal, but we don't have the strong atmospheric signal. Now, the key is it is not unusual for El Nino to pause or stall in the May, June, July timeframe. I went back and looked at all the historical El Ninos, and probably out of half of them, they all stalled somewhere in June and July. And I think it's more of a seasonal sort of thing. You're just in literally the doldrums of summer, and that's exactly where we are right now. It's still like there's hangover from winter and La Nina going on. There's not a lot of activity. I'm a surfer too. There's not even any surf. But most surfers understand El Nino is the godsend for surfing because it supercharges the jet stream. When the jet stream is stronger, that helps produce storms in the winter months up in the northern hemisphere and in southern months down in the southern hemisphere. And California is blessed with the ability to get swells from a very large direction, from up in the North Pacific or down off of New Zealand in the summer. So the surf season has been horrible right now. We've had no southern hemi swells, and the expectation is that once El Nino gets baked into the atmosphere, probably one of the first things we'll see is a storm off of New Zealand. And then and if you get 1 and 2 and 3 and you get sort of a pattern going, then we'll know for sure that La Nina is washed out.
Every major meteorological organization around the globe tracks El Nino because it is a major pattern driver for the planet.
The latest consensus model is suggesting anywhere from a high moderate to a low grade strong El Nino. It doesn't look like we're going to move into super El Nino territory.
But this still isn't a perfect predictor of what our winter might look like.
So we're looking at sea surface temperature patterns around the globe, looking at how those correlate with weather or seasonal changes. And I'll tell you, those correlation kind of coefficients, or the magnitude of those correlations, are never a home run. You talk about a really good baseball player, might be batting 300, 350. What there's a guy batting close to 400. That's about what those correlations are in terms of trying to predict. So they give us a clue, they give us a hint as to what the pattern might be, but no El Nino and La Nina is created the same. It often works out that when we average the patterns up globally, we see kind of what we expected, but when you boil it down to one location, whether that be Sacramento or Australia, which had some rain this year despite El Nino, more being a drought influence there, and then going down to South America, if you get down into the nitty-gritty, things break down pretty quickly. It's more of, like you said, a global pattern. When averaged out, those correlations hold up.
So, assuming the forecast verifies and El Nino gets going, that typically means an average to above average rainfall year in California.
I mean, I'm not a water management guy, but, if your reservoirs are at 100% and then you dump another 150% of normal precipitation year on top of that, I think the folks in the water management business are going to be very busy this winter if El Nino develops as strong as forecast. So that is kind of the theme of all this. We're stalled right now. Is it going to wake up? And how strong is it going to be?